Okay, so first of all, thanks for coming. It's like Go's been around for 5 years now, I think. The 5th birthday of an amazing language. And at SoundCloud, we've been using it for a long time, I think actually pre 1.0 release for some internal tools. So today I want to talk about basically Go in the context of companies like SoundCloud, which I'm calling the modern enterprise. So first I want to talk about what I mean by that. What is a modern enterprise? Why I think it's important. I'm going to talk about my experience at SoundCloud, specifically like our product evolution and the infrastructure evolution. I'm going to talk about how I think that generalizes to other companies in our space. And I'm going to talk about what I think Go needs to succeed in that space and how we've kind of like, in some ways, missed the boat, unfortunately, and what we can do to make up ground. So first of all, the modern enterprise. What do I mean? This is what I think it is. It's companies that are somehow tech-related, probably consumer-focused. They almost certainly have achieved hockey stick growth in their nascent lives. They probably have at least 100 engineers, so a sizable company. And probably they also have what we know is like a service-oriented architecture. A company doesn't have to tick all the boxes, but probably most. So what are some companies that kind of spring to mind when you think of this sort of thing? This is what it is for me. So obviously Google is quite large, maybe too big. I would like kind of cross them off the list. Amazon is kind of in maybe the same way, like maybe they're a bit too big to be considered in this space. And there's a whole class of companies like Etsy, which actually operates basically monolithically, like not in an SOA style. So I'm going to cross them off the list as well. And that leaves like companies in this space, I think. They share a lot of properties. They are pretty big. Twitter's, I think, the biggest of these. Maybe Netflix is bigger now, actually. But I think they're like 1,500 engineers or something like this. SoundCloud, we're much smaller. We're like 120 or something like that. But these are like what I consider to be the big players, but it's not by any means exclusive list. If you kind of drop some of the requirements, there's a lot of companies, and these are just the ones that I know use Go, that kind of fit into this space. So this is the type of organization I'm talking about, and I guess I want to emphasize that they're kind of driving a lot of conversations in the tech world, in my view. A lot of technology decisions being made by these companies, or these companies, are kind of being replicated by other companies. And that's the thing that I kind of want to talk about today. So let me talk specifically about my experience at SoundCloud. This will be kind of a pretty common story if any of you are familiar with this kind of architecture. In the beginning, there was the Rails monolith, right? Everybody knows about these things. At some point, we realized this is unsustainable, so we start breaking out little services out of it, right? Has anybody so far has worked in an organization that's worked kind of like this? You're kind of at this space so far? Okay. So you follow this path a little bit more, and you end up with like some services, right? The monolith is still there because it will never die, but this stage is what I'm going to call like SOA, service-oriented architecture. Okay, great. You keep going a bit longer, and like this starts happening, right? And I guess this is what people mean when they say microservices. It's just like more of them, and they're maybe a bit smaller, maybe a bit bigger. I don't know. Now there's like this term of art called like pico services. Has anybody heard that? Like I don't know what that would be. Like presumably some terrible constellation, or like even like nano services. Like holy shit, right? Yeah. So let's go back to this. This is kind of where we were, I don't know, a year ago, like 2 years ago, a year and a half ago. And this is already getting out of hand, right? So what we started to do was figure out a way to make these pieces make a bit more sense. And so we did something like this. You group services by broad like role, and you kind of arrange them into tiers. And you can assign those tiers kind of like jobs in some broad way. And I'm going to coin a term. I haven't seen this before. I'm going to call this like structured services. And so this is how we are today. We're kind of like a lot of services, like a microservice thing, but they're arranged in these tiers. And they interoperate in a kind of a specific way. So structured services, what do I mean by that? I'm going to claim that structured services are SOA in the modern enterprise. That's kind of where I see the trend lines going. And by structured services, basically I mean structured RPC. These services communicate with each other using, I don't know, HTTP JSON or like Thrift or protocol buffers or whatever, but fundamentally it's a request response kind of like paradigm. So in our specific case at SoundCloud, the way we have it cut up, we have at the top tier a set of specialized APIs, basically one API per client thing that we serve. So we have an API for our iOS devices, an API for our Android devices, for our web, for our mobile web, you know, all these sorts of things. And they're exclusively concerned with producing output that is tailored to that device. So if you have a web client, you probably want a lot more detail than you do on your iOS client. We have different backends to support that. The next layer down, kind of the biggest layer, is our business logic layer. And that's like producing all of this stuff you want to see. And then at the bottom, we have our data model. And this is actually the smallest of all these layers. This is the data services that surround like MySQL instances or Cassandra instances or Roshi or whatever. So consider the life of a single request. You open up your SoundCloud app and you hit refresh or whatever, and in it comes, and maybe, if we're lucky, that'll do like one of these things, which has to hit that machine, and then it needs to get some more information here, and that does that, and then go here, blah, blah, blah. This is actually totally typical, right? And in just a single call, we see in this diagram, we have one incoming request that fanned out to 9 services and ultimately 14 RPCs. And this is actually minimal, right? Most things go up to an order of magnitude bigger than this. This is the universe that we kind of live in now. So let's consider just one of these like little RPC things. And we'll get to go in a minute, I promise. So here's like a client server. What do we care about in this interaction? Certainly, we need metrics on the client, right? The app metrics, same stuff on the server. We need metrics on this like connection on the like information itself, both on the client perspective and the server perspective. We need implementations of things like back pressure and request limiting on the server side. Similarly, we need like protection guarantees on the client side, like circuit breakers. At a high level, we need an ability to cut through different transport layers in the communication channel. We need higher order concepts like service discovery to like figure out what we're talking to, what instances are alive, their healthiness. Over the whole system, we need concepts like request tracing. I guess this is like Dapper or Zipkin, so we can see how requests flow through the system, identify problems, this kind of thing. And this is like, I've even missed like a bunch of stuff here, but this is kind of like bare minimum stuff, right? In order to operate this huge distributed system, we need all these things in our like client server libraries, basically. So how do companies do it? How do the modern enterprise do it? Well, as far as I can tell, this is how it kind of works. Google and Amazon are big, and they were kind of like pioneers. So they use a set of languages and sort of their own internal like libraries. Not a lot of this is open source. But in this middle bit here, you see kind of like a homogeneity. It seems to me, through my lens, these modern enterprises have settled on a JVM stack, and then primarily Finagle. In Netflix, they have their own kind of like set of libraries. And I put stars next to SoundCloud because we haven't really like gotten all the way there yet, but it's definitely the trend line. And this makes me really sad, actually, because when we started this process, Go was definitely in the running, and Go lost, right? And Go lost and Scala won. And that's kind of sad to me, obviously. So how did Scala manage to win this battle? It had a success story with Twitter. Twitter did this like, I guess 4 or 5 years ago when they had that big transition from Ruby to Ruby on Rails to like their current architecture. It does give reasonable performance for certain people's definition of reasonable, not really mine, but my voice is small. You get reasonable business domain expressiveness. And from these first 3 things, you get this last thing. You get mindshare. You get people talking about it at conferences, and you get developers excited about it. But Scala is obviously not a panacea. There's some really terrible things about Scala. there's one person in my company that likes Scala. His name is Georgi, and he's all about it. But literally every other developer uses it in anger, right? Scala has an objectively terrible toolchain. The compiler is awful. Like, all the surrounding stuff is really bad. The language design itself is confused by like this mishmash of like academia and industry, like trying to reach some sort of consensus. And as a result, nobody actually understands the language. Like, there's a ton of like cargo cult copy-paste stuff, like a surprising amount, even at the highest levels, as far as I can tell. So, like, this isn't like the permanent state, right? There's opportunity for improvement. So Go does some things right. And from where I sit in this like enterprise environment, this is what I see as like Go's strongest selling points, right? This objectively awesome tool chain, this extremely coherent and like considered language design. I can't overemphasize how important static native binaries are. That's really great for like from any dimension. It has really great efficiency and performance, especially compared to Scala. I've done basically benchmarks where you compute memory used and CPU burned per like request processed. And like, okay, we run some Nginx processes, they win, that's like benchmark level 1. Go is like typically 10x, 1 order of magnitude greater. Good optimized Java is usually about 100x. Scala is like 150x. And then like the Rubies and the Pythons are around 1,000x, rough order of magnitude. So Go has a good case here. We have really great micro conventions. I put micro in brackets, I'll explain what that means. And we have a lot of like micro success stories, like companies who have written blog posts. We moved from X to Go, and it's like been a great thing. So this like builds mindshare. This is great. This is what we need. But it's not all like sunshine and roses. Go's very young, and that actually plays in a lot of people's minds. In my opinion, we have an overemphasis on primitives, especially in this environment. There are big holes and caveats, and I can explain them to other developers, right? But they still, like, it's kind of an unsatisfactory explanation. I think we can all think of the elephant in the room there, but there are other ones too. In my opinion, we don't really have higher order conventions at the moment. And we don't have any big success stories in the sense of like, choosing Go has allowed my startup to have 100x growth, and here are the reasons why. I'd love to see that sort of thing. So what I want to kind of advocate for, and what I want to say that we need, is to embrace and extend the positive stuff that I identified, and to spend some energy as a community on these negative things. So now to like the meat. What do I think we actually need? And I put a star here because this is definitely just my opinion, and I'm eager to have a kind of a conversation about it, but this is my perception of things that I would make my job a lot easier in the environment I'm in. So first of all, I think we need fewer blog posts about request muxers, but I think you know what I mean, right? Like, everybody has a great story about writing a request muxer, or maybe like a command line tool that's like really cool. And don't get me wrong, it is really cool. But we've had a lot of these now, and I'm interested in something maybe a bit bigger. Like for events like this, CockroachDB, for example, awesome. Let's spend more time thinking about that sort of thing. If you are able to patch together like a interesting high-level framework for, I don't know, something you're doing at your company that involves multiple Go things, that would be very interesting to hear about. Even if it's not like super clean, I would love to read that sort of thing. I'd love to read more blog posts about things like composable interface design, or specifically the context package, which I think is a really cool thing. And like all I really have to go on, all I have to point other people to, is that excellent but singular post on the Golang blog. If you're using this in a kind of an interesting way, please like get it out there. I think we need more like contextual, maybe operationally informed posts or discussions about things like application instrumentation. Like if you run Go at scale or any language at scale, you know you need this kind of stuff. But as far as I'm aware, there's not like a lot of conversation about this sort of thing. In general, I would argue we need more like blog posts about elegant patterns and the things that they enable. And for me, the canonical example is the one Rob Pike gave about his parser lexer, which I really enjoyed and which pretty much everybody I show to has their mind blown, even just like for a minute. And that's really great. And I think Go is one of the languages where the gap between what exists and like having your mind blown just a little bit is very small. And we can make a lot of posts like this, but I don't think we're doing enough of it. Okay, community type stuff. This is kind of near and dear to my heart. I think we need a more coherent build story. Right now, we exist in this like open source world, and that's great. And indeed, in my organization, we have this saying like, we operate as a sort of an enterprise open source economy, which means we have these teams which are responsible for like features, and they're kind of independent of each other. They produce their own like kind of full stack whatever, and they push to their own repos. And if other teams want to use that stuff, they can. But the relationship there is sort of an open source relationship in the sense that they can be expected to submit pull requests when they want new features. They can be expected to adapt the code to their own uses if they want to do that. And in this environment, actually, the Go model is pretty good. Specifically in the context of a build story, like if you want to go get somebody else's Go library and then and use it in your own project, probably if it's external, you would probably vendor it. Otherwise, you can just use it directly. That works great. For external libraries, we have kind of circled the drain for a long time, and it looks like where we're ending up is go-dep-r, which means vendoring everything and rewriting the import paths. I think the Rocket people do this as well. It seems to be the path of least resistance. So this works okay, but like we have this single universe, right? We control all of our own code for the most part, and that we don't, we can treat as a dependency. So we have this universe, and it would be great to be able to leverage it. I don't want to lean on the Google people, but I know you also have like your strong own universe. If you could give us like some stories about how you've leveraged that to like get interesting things. For example, I'm thinking specifically of like controlled lockstep upgrades, refactoring over the whole code base, like this sort of thing. Like we want to do the same thing in our environment. We're maybe a little bit looser in terms of like the restrictions that we have. So maybe that opens up some doors. But we want to do this sort of thing. And right now, there's not a lot of clear guidance. OK, so a coherent build story. Going back to the other stuff I mentioned, what I really want to argue for and what I'm feeling the biggest need for is a higher order framework for what I call structured services. So let me actually do a bit of a deep dive into this because this is what's really like motivating a lot of my thoughts recently. Here's the same diagram. And this is like a minimal thing. But let's look at all these like pieces, and let's think about what Go packages to serve all of these things might look like. So let's start with metrics, right? Everybody needs good metrics. I can imagine a package metrics that has primitives like gauges, counters, histograms. Because we have such strong Go conventions, I would expect it to be all that information to be sourced from xvars, the canonical standard library way of instrumenting your application code. I would expect pluggable like exposition to other systems, graphite. I can't even think of another one. What are some other like graphing and like metrics? StatsD, right? FluxDB. Okay, yeah, definitely. Influx, yeah. OpenTSDB, for example, yeah. Some pluggable interfaces like that. I think for all these things, it's important to consider prior art. And in this case, prior art means Coda Hale, who's like the metrics guru. We built actually a monitoring system at SoundCloud, which is now open source, called Prometheus. There's a lot of good thinking there. It's built by, well, former Googlers who wanted the Google experience in the open source world. So take a look, plug, search it. It's good stuff. So package metrics, maybe. Think of like the package server. Obviously, you wouldn't call it server. Maybe you'd call it something else. But it would be responsible for things like declaring and enforcing these conventions that I described about back pressure and this sort of thing. Connection pooling, like how to handle not only like the happy path for servers, but also when things start to go wrong, handling all that in a kind of understood and like non-surprising way. When you build a distributed system of like 1 billion pico services or whatever, you gain a lot of things. And to be clear, we'd never go back to the old way. We gain so much by having these like independent channels of like distribution and deployment and like defining strict contracts and all this stuff. But you do lose some stuff, right? You lose like this ability to understand what the system's doing overall. So we need like conventions. We need strong conventions that are enforced at a language layer, at a package layer, to make sure that we can like make sense of this distributed system that we've built. So I want ways to do all of these things. I want multiple strategies for each of them, so I can decide with some limits what's important for like my specific use case. Package server should probably publish to a service discovery layer. In fact, it should definitely publish to a service discovery layer. What that means, I'll get into in a second. And again, prior art. Finagle does a lot of this stuff, and quite well, I should add, sometimes in a lot of places. Carrion, I think, is the Netflix equivalent. It's like the server side of their stack, and it like sets up a lot of stuff for you, basically. There are others. Does anybody? I'm curious for myself. Does anybody know of anything else that fits in this like space? No? You can come find me afterwards. I'm really curious to learn more, actually. So what I want, actually, is to define my service in terms of basically a Go interface, right? It'll have a couple things that you can do to it, like, I don't know, something like this. And if it means that, if integration with this like framework that I'm describing means that I have to like throw some extra stuff in the, like pass a context at the beginning or something, I'm happy to do it, right? I want to pay the tax. I'm willing to lose interface purity. I'm willing to lose some performance cycles if it means I can extract all this extra value in the distributed system. On the client side, kind of the same stuff, declaring and enforcing conventions. I want the same kind of modules for rate limiting, for circuit breaking. These are common nouns that like kind of everybody's familiar with. But I want to be able to do that declaratively with multiple strategies. The client package should subscribe to the same kind of abstract service discovery thing. And again, there's prior art and Finagle. They kind of capture both sides of the thing. Ribbon is the client side of the Netflix stack. Maybe there are others as well. Let's talk about service discovery. That's like the big topic in configuration management and clustering and blah, blah, blah. It's such a big topic. There's so many competing like paradigms right now that I wouldn't deign to like claim that one is the best. So I think it needs to support multiple methods, from like very simple primitive things like DNS-SRV lookups. There's like the centralized model, which is console or etcd, or I guess Zookeeper. There's a hybrid model. If you haven't heard of this, Airbnb basically has a single authoritative source of information, like a Zookeeper, I think it is. They push that information to every host in their infrastructure, where they run a local load balancer. So all the applications to talk to other applications, they just talk to localhost, and then all the routing information is kind of handled for them. I consider that kind of a hybrid model. And these are all valid, right? It all depends on what you're trying to do, where you are in your organization's like evolution. But we need somehow support for that in my vision. And then the thing bridging all this together is somehow like some transport package that will take all these idioms, client, server, service discovery, and bridge them to the like fundamental implementations using any number of things, right? Because we need to make decisions at this level too. HTTP, protobuf, thrift, Avro, package RPC would be great if you're dealing in a pure Go kind of world. They should all be interoperable. Maybe we can build this stuff with Go Generate, something like this. I'm sure there's prior art. I'm sure there's inspiration to be had in the standard lib, but I'm not sure exactly what it would be there. And then when we have all these things, what I would love to see personally also is something like a package inspect, right? Where we have the system with all these conventions. We paid the tax at all of like the lowest levels. Now we can reap the benefits of that. We can get introspection of our like running distributed system. We can get deep analysis at a cost, right? And here there's a lot of prior art. Google's Dapper, which I think the name escaped into the world, but the implementation didn't. Zipkin is like Twitter's attempt at doing a Dapper thing. Even something like JMX would be amazing to have in a kind of like a controlled way. And I think there's a huge amount of value that the modern enterprise needs and indeed expects that can be accomplished in this way. So that's basically it, but I would kind of like close on this idea that I think now we're like 5 years into this project, right? And we have so many success stories, but I think we're kind of in some ways stuck. We're stuck at this layer of abstraction that we haven't ascended beyond. And I think it's time to start climbing this ladder, right? This ladder of abstraction. And I think there's a lot of benefits to be had here. I don't know what they are. I've presented my vision. Maybe you have also a vision. I'm really, really, really happy and like excited and motivated to talk to each of you. If you have similar ideas, maybe form like some sort of working group. We can talk about this sort of thing, get some minds together on it, and push something like a standard out there. Because I think Go is like the perfect language for this modern enterprise SOA kind of environments. And I'm really excited to push it in a way that makes it a success there. So, I mean, that's basically my talk. So please get in touch. And I'm happy to answer questions, too. Anyone at all? Yes?
How did you end up handling service discovery in SoundCloud?
It's service discovery. It's a topic of active consideration. We, about a year ago, pushed service discovery to the DNS system. So we use DNS SRV records right now. That's only taken us so far. And right now we're rolling out basically a console-based implementation. Console also does DNS, so it's a drop-in replacement. And then we add more like publish, subscribe stuff on top of that later. Yeah. So centralized model, I guess, as I described it. Yep. Yes?
How do you interrupt between finagle services and Go?
And so at the moment we don't, right? And that's, yeah, sorry. How do you interop between finagle services and Go services? And at the moment we don't, unfortunately. But that's definitely a goal. I mean, ultimately they talk using a protocol. Like currently it's almost exclusively HTTP JSON, no problem. But we don't get like the Zipkin-based request tracing. And I'd want to see in a Go framework exactly that kind of stuff, exactly that kind of interop. I want to build it, right? But I need help, I guess. Yeah. Okay, cool. Thanks again. I'll be hanging around here all day.